Here comes solving a system of 3 linear equations with 3 unknowns using Gauss-Jordan elimination. I will try to keep my commentary to myself. Begin by writing the augmented matrix 1, -3, 4, cross the line, 30. Next, 2, 1, 1, on the other side, 4. Next, -2, 4, -3, -32. Okay then, now when we do this, we want to get a 1 right here, but look, we've got a 1, so that's very good news. Okay, well, now that we have a 1 there, let's put a 0 right here. To do so, we need an operation, a times row add. Let's do 1 times row 3 and add it to row 2 to replace row 2. Since you can see that we've got opposites already in place. Okay, when we perform this operation, notice how rows 1 and 3 stay the same. But we did get what we were hoping for, a 0 right there. Our next objective is going to be to get a 0 right here. To do so, we need the opposite of -2, that is +2. Let's multiply 2 times row 1, add it to row 3, and that will replace row 3. That's our operation. This time, rows 1 and 2 will stay the same. But row 3 is now different. Okay, so the first column, observe how it is perfect. We've got to work on the second column. We'll work on getting a 1 here. To get a 1 there, we must multiply by the reciprocal of 5. So we'll multiply 1/5 times the second row, and that will replace the second row. That's our operation. When we do so, the first and third rows will stay the same. We've got 1, -3, 4, 30. Now we've got 0, 1, -2/5, and -28/5. The third row is 0, -2, 5, 28. Well, we've got the 1 in the second column, so let's work on getting zeros. A 0 here, then there. So, to get a 0 up here, I would need the opposite of -3. I need a +3. Let's do a times row add. 3 times the second row. Add it to the first row. Give yourself a little shake, and that will replace the first row. Let the fraction times begin. Our first row will be 1, 0, 14/5, 66/5. Second row is 0, 1, -2/5, -28/5. And the third row, 0, -2, 5, 28. At this time, we want to work to get a 0 right here. To get that 0, we need another times row add, a +2. So let's make this operation. 2 times the second row, add it to the third row, and this will replace the third row. Notice that the first and second rows will remain unchanged. 1, 0, 14/5, 66/5. We've got 0, 1, -2/5, -28/5. But the third row now is 0, 0, 21/5, and 84/5. Oh, it's a mess. Now the first and second columns are perfect. Let's work on the third column. Let's get this 21/5 to turn into a 1. In order to get a 1 there, we're going to need to use the reciprocal. So let's multiply row 3 times the reciprocal, 5/21. So 5/21 times row 3 to replace row 3. The first and second rows remain unchanged. 1, 0, 14/5, 66/5. Luckily, these are all nice decimals. 0, 1, -2/5, -28/5, and now 0, 0, 1, 4. Oh, thank goodness. Fewer fractions. Let's work to get a 0 here. To get a 0, we need a times row add. The opposite of 14/5, -14/5. Let's multiply -14/5 times row 3, add it to row 1, and this will replace row 1. The result of this operation is 1, 0, 0, 2. Oh, that looks so much better. Then we still have 0, 1, -2/5, -28/5, and 0, 0, 1, 4. Okay, one last thing to do, a 0 right here. To turn that into a 0, we need the opposite of -2/5, +2/5. Let's take 2/5 times row 3, add it to row 2, and this replaces row 2. Okay, when we do so, the first row is not changed, but the second row is 0, 1, 0, -4. That looks better. And the third row. Now we have row reduced echelon form. We can see that x is 2, y is -4, and z is 4. Written as an ordered triplet in order 2, -4, 4 is the solution to that system using Gauss-Jordan elimination.